Hello, good morning. Happy Friday. All right. What's up, Arnav? Hey, good morning, everybody. How's everybody doing? You guys good? Let's go. Yes. 100 on your math quiz. Nice job, Aaron. Way to go. I don't know if I've ever gotten 100 on a math quiz my whole life. Keegan, what's up, man? Keegan, if you want to do me a kindness and send me a message with the assignments that you still need to turn in, that would be great, because you've had issues with Canvas and stuff, I know. I'll take care of it. Some of the stuff that you handed in, though, just to let you know, you handed in like the same assignment twice or the wrong thing or whatever, so you didn't get credit for everything that you uploaded. But if you have them done, then you need to email them to me soon so I can get those added to the grade book. Or message me on Canvas, rather, and just attach your assignments to your message on Canvas. Kevin Wong, what's up, man? Angie, hello. How am I doing? I'm doing great, Isabella. I got your message. Okay, sounds good, Keegan. Isabella, I got your message about the point. To be honest with you, in the grand scheme of things, it's not going to make a whole lot of difference, but I do appreciate that you did that. I tell you what, I'll give you half a point for it. How about that? Do we submit something? No. Well, yes, but I was talking specifically to Keegan because he had some things that he had to hand in. But is there anything due for today? Yeah, there should have been like a test that you took last time. That was the thing that was due. And then, yeah, if you guys didn't see this message, I got a number of messages about this, or reminds, or whatever. The test, the matching question on the test is worth 16 points because it's 16 different terms, but it doesn't allow me to give partial credit for that. So even if you only miss one, it'll look like you got 16 wrong. Don't freak out about it, okay? I just have to go through, and just don't trust the grade that you got on the exam when you finished it. Just wait for me to put the grades into Q, and I promise you the grades that go into Q will be the right ones, okay? So, and yeah, 90% is great. That's fantastic, of course. Okay, so we are going to get started here with the next unit. So I'm going to go over to Canvas here. And on Canvas, we are going to go to the Files section. And in the Lecture PowerPoints folder, I am now uploading the new PowerPoint for Unit 2. And then today there will be a vocab assignment. Which I will explain how to do in a little bit here. I'm just trying to get the thing pulled up. So if you go into the files section on Canvas and lecture PowerPoints, you will now see the Unit 2 PowerPoint. Please do download that so you can be following along. I still have not been given admin credential things on my computer, so I still can't screen share yet, but I'm hoping that that change is coming up soon here. And go ahead and open up that Unit 2 PowerPoint, and we are going to dive right in today talking about this new unit called Enlightenment and Revolution. Okay, and we're going to be talking about the scientific revolution and enlightenment, as I mentioned to you guys yesterday. And what we are increasingly seeing in this era in history, which is we're starting with the 1500s, and actually I'm going to give you guys a little bit of stuff to remind you of just how different the world was in a pre-scientific revolution era. Okay, in the ages of the Renaissance, right, the ages of the Reformation, the notion of scientific thinking doesn't really exist. Okay, the world wasn't thought of on scientific terms. Okay, the world was thought of on very superstitious, mystical, religious terms. And anything that we take for granted today about like modern medicine is in just simple understandings about how the world works and how there's laws of physics and all of this other stuff, right? These ideas don't exist for the population. And so the question is, where do they happen? And the scientific revolution is where we start to see people questioning the world around them in a brand new way. Why does this happen? Well, we talked about that guy, Martin Luther, who started questioning the teachings of the Roman Catholic Church. For the first time in 1,000 years, the Roman Catholic Church's authority gets questioned by Martin Luther and various others. Okay, and so people start breaking away from the church, and the church no longer has this intellectual stranglehold on the population. And during the scientific revolution, people start realizing, like, oh, gee, maybe everything that we thought we knew about the world isn't exactly right. See, what you guys have to understand is in a pre-scientific era, when people explain pretty much all phenomena as being a product of God and divine intervention and stuff like that, divine intervention meaning like God coming in and causing fires, causing plagues, causing this, causing that, as a product of punishing people for their sins, or miracles. They could be good things too. Divine intervention just meant any way in which God intervenes on a daily, day-to-day basis in the everyday lives of people. And there was no real understanding of like, well, but why does this happen? According to, just non-religious, non-spiritual, but just, scientific explanations of things. And, the clearest example of this, a lot of times people will say, oh, well, did Christopher Columbus think that the earth was flat and that they were just going to sail off the edge of the earth? No. Okay, they didn't. They knew the earth was spherical in nature. They didn't know exactly the size of the earth, but they had a really good idea going back a long time ago. All right. And so, oh gosh, Arnav just said something. What did he say? Society needs to question authority today. I don't disagree with you. We should always be questioning authority. Isaiah says, chill. It's okay. You know what, Arnav, I respect that you're a thinking man. I will tell you that right now. Arnav he's a thinking man, and that's a trait to be praised, right, in modern day times. But the most clear example of just a simple phenomena that people just didn't have their brains wrapped around yet in a pre-scientific era is that, they may not have thought the earth was flat But I want you to think about something. Common sense. Let's talk just briefly about this notion of common sense. We use this phrase a lot. We think of common sense as being things that are just boneheaded things that people ought to know, right? And it's like, it's just pure common sense. Don't touch a hot stove, right? If you don't want to get burned, don't touch a hot stove, okay? Or something like that. It's common sense, okay? It's common sense. Well, common sense, that term has a tendency to get extended to things that are just really not that common. Meaning that people say it's common sense, but it's like it's not really common sense unless you have an understanding about it. And so, like, the best example, and I know I've been building this up a lot, but the best example is something called geocentric theory, and I'm on slide 2 of the PowerPoint right now. Geocentric theory was in a time before astronomy had taken off, in a time before physics had taken off. People looked around them and observed the world around them, and observed the stars, and observed the sun and other things, the moon and whatever, all these planets, stars, suns, or sun and moon, and they observed them. And from a common sense standpoint, right? Let's think about it for a second. You're on Earth. You don't feel the Earth moving, okay? You don't feel the Earth moving. You don't feel the Earth spinning around. You don't feel the Earth hurling through space, okay? It feels like the Earth is still. And so according to common sense in these times, the Earth was this immovable object stationed exactly in the center of the universe, okay? And because people backed that up because they were believing in God and the idea that God created the universe, God created Earth, God created man, God wouldn't make a mistake. God wouldn't make a mistake and put Earth somewhere not in the center. Why would he put Earth somewhere off to the side in some peripheral part? It doesn't make sense in their brains. And then they see the sun rise in the east, move across the sky throughout the day, and set in the west. They see the sun moving. So according to common sense, in their minds, the Earth was stationary and the sun and everything else around the Earth was moving around the Earth, okay? This is obviously not true, okay? It's wrong. And that's just not how the universe works. And we know that today, but we only know that because people started asking questions of, maybe what we believe in terms of common sense about the world may not exactly be true. And this is dangerous in that time, because if you were to challenge the church in particular, you could find yourself, very quickly excommunicated, labeled a heretic, burned at the stake, or whatever. Angie, let's see, probably a stupid question, but why did so many people follow Jesus or believe in a God or higher spirit? I want to know your opinion. Well, to be honest with you, there's an advantage to it. So humans, in a pre-scientific time, the reason that religion operates as a construct amongst humans is because when you have many humans believing in something greater than their individual purpose, humans bind together under a common belief set and are able to, using those beliefs, able to become inspired, perhaps like, let's say they were going into battle or something like that, and they all believe that God is behind them. They might, just because they believe something, there's a lot of psychological studies that demonstrate if people have a belief in a higher good, like maybe even on a smaller level, you could talk about like a football team or something like that, or any other sports team where, you're not working for your individual achievements, you're working for the betterment of the team and working together. And there's this higher degree of spirit and core values of the team. And things like that. Well, religion takes that to another level, right? Because now you're dealing with all powerful beings that they believe and stuff like that. And so there's like this, there's an advantage, for local people who are, we're still on slide 2. I'm just keeping on talking. I hope you're not bored, Kevin. But there's an advantage for people to be able to bind together under a common belief system and prevail against others, maybe even against the odds. And also, too, you got to remember that people's lives at this time were pretty grim. They're pretty dismal. right? It's a tough time to live, and there's a lot of death and stuff like that. And having something to believe in about this existence being just temporary, that this existence of suffering and difficulty that people had to go through in order to exist, that afterwards you would go to heaven or something like that. This makes it so that your existence on earth it becomes less important, and that really what you're trying to do is just live a good life in order to get into the afterlife. And so there's two, there's creation stories and all of these other things. And then, like we talked about last unit, religion does offer some degree of communitarian spirit, right? Like as a good religious person, you're supposed to act according to the moral codes of your religion. Don't kill other people. Don't, cheat on your wife. Don't do this. Don't do that. And so there's a whole lot of like basic moral principles that kind of bind these people together as well, in order to make their communities perhaps a little bit more livable. But once you start to see Christianity take off and really much of Europe becomes Christian, there are power structures that flow there. And the Roman Catholic Church, as we've talked about, started to become really, what is it with you two today? Chill out. All right. And so anyway, the point being, I guess, that I'm trying to make is that religion does have a function in society to help people live better, and also believe in something bigger than themselves, right? These days we can look at the same ideas: don't kill, don't cheat on people, whatever, and we don't even have to necessarily ascribe any religious meaning behind it, because just on a purely human level, society works better when we walk outside and we don't have to worry about folks killing each other and all this other stealing and other things like that, right? Like society functions better. Humans, just on a purely secular level, function better by, having a communitarian spirit absent of any sort of communal religious beliefs. But that's just, that's more of modern day philosophy and stuff like that. But that's a long-winded explanation. But by the way, not a stupid question. That's a great question, Angie. So I appreciate that you asked it. Okay, now moving forward here. In the mid 1500s, scholars started challenging the ancient thinkers of the church, and oh boy, Arnav, here we go. All right, and then there's a new way of thinking about the world. So moving on to slide 3 now, which I'm sure Kevin will be happy with. Another thing about this was, we got to make sure I'm watching the time here so I don't go late. Okay, so another thing about this is that travel to new areas started making people question what they believed about the earth before as well. Because you have to understand that Europeans in a pre-Columbus era, before Columbus went over to the New World, Europeans really had no idea about what was on the other side of the ocean. There was no reason for them to go over there up until there was a reason for them to start exploring, in particular the Spanish and the Portuguese. And so what ends up happening is, once the Spanish and Portuguese sail across the ocean and they realize, holy smokes, there's this whole huge territory that we didn't even know existed on Earth's surface, with all these Native Americans living on it, they start questioning what they believed in back in Europe, because suddenly, with the age of discovery, with the Renaissance and all these things, suddenly the world that used to make sense to them now is making less sense to them. Okay, and Europeans for a long time, under the Roman Catholic Church's intellectual stranglehold, had not really developed many inventions, new innovations. It's kind of this medieval dark ages where there's relatively a lot of feudal fragmented kingdoms and societies fighting against one another and stuff. And then when we get to the late 14, early 1500s, what we see is these new understandings about things, these new questions, these new innovations, these new inventions that start to be developed. The printing press gets developed. People start to read more. We were living in a long time where, the Catholic Church, there was virtually nothing that was circulating around except for theological documents that were written in Latin, which was a language that no one spoke anymore. And so the vast majority of the European continent was made up of people who couldn't simply read. They couldn't read or write. They were illiterate. They would have been able to speak local languages with the folks in their community. But other than that, the vast majority of folks couldn't read and write. When we get to an era where the Gutenberg printing press is circulating around and more stuff is being written in their local languages and they're able to read that stuff, people start to become better educated. And when you become better educated, you start asking questions about things because you know more. And so this printing press spreads these ideas around. We have new ideas developing in astronomy in particular and mathematics, and then later on down the line, physics, biology, chemistry, stuff like that. We see new inventions in navigation as well as instrumentation for science. So like in the late 1500s, the microscope gets invented. We see new inventions from the scientific revolution that are like barometers, which measure air pressure, thermometers, which measure the temperature, and other things like that. And then too, like navigational technologies like compasses, and there was devices that allowed you to like measure the stars and their movement, called like a sextant or an astrolabe. And these devices allowed Europeans also to be able to navigate across the ocean and know relatively where they were on Earth's surface. So tracking the movement of the stars came originally about as a product of like this wanting to know where we were on Earth's surface and be able to measure according to the stars and where they are at the sky and the angle that they are from the horizon and stuff like that, that you could tell where you were on Earth's surface. But in the byproduct of that is that they also are looking up to the stars to make better sense of the shape of the universe. Okay, and this geocentric idea started to not make sense the more precise these calculations of star movements became. And so the more precision that they had in measuring star movements and planetary movements and stuff, people were trying to do the math to figure out like, how are these things moving? And the math just didn't make sense to people. Previously, the people assumed that all orbits were perfectly circular. And if you know anything about astronomy, you know, when the Earth moves around the sun, it's not because the sun is in the exact center, and it's not because Earth's path around it is an exact circle. Okay, we move in an elliptical pattern around the sun. And there are times where we're closer to the sun, and then there's times where we're farther away from the sun. We're not even like perfectly centered in terms of moving around the sun. And some of the math, as people became better at measuring the movement, it just wasn't adding up. They were like, what's going on here? Something isn't right about what we think about things. So we need to figure out what's going on and get a better picture here. But of course, this is going to challenge the teachings of the Roman Catholic Church, which really doesn't want itself being challenged, of course. And the first guy to challenge geocentric theory, this idea that Earth was in the center, is Nicholas Copernicus. And on the next slide, you can see him on slide 4. On slide 5, Copernicus starts saying, you know, the planets, the stars, the Earth, all of it revolves around the sun, that the sun is in the center of everything. And he called this idea heliocentric theory. Okay, now at first it doesn't gain a whole lot of attention from the church because they're so preoccupied with what's going on with Martin Luther, this guy talking about the Earth and the sun. They're not interested in it. But when they start realizing, this goes against what we've been teaching for years about the formation of the, you know, when I say years, I mean centuries. This goes against centuries of church doctrine saying that the Earth was in the center because God created Earth and he made it perfectly in all circular motion and Okay, they start realizing that this is a threat to their ability to control the narrative of what everybody believes about things. And so they later start rejecting this idea. And so that's kind of the story there. Now, there was another guy that you should probably be aware of, and his name was Tycho Brahe, or Tycho Brahe. Tycho Brahe I think he was Dutch, if I remember right. Or no, he was Danish. He was a Danish astronomer, and he had a student by the name of Kepler. Now, ironically, not everybody believed right away that heliocentric theory was true. Nicholas Copernicus's ideas were radical. Not everybody, just jumped right on board with what Copernicus said and just took it as truth. And Tycho Brahe was one of these people who said, this guy Copernicus, he doesn't know what he's talking about. The Earth is in the center of the universe. And Tycho Brahe received a whole bunch of money from the Danish king, who which allowed him to build this massive observatory. I think it's on like a little island called Haveen, if I remember right. But anyway, it was totally dark in Europe at that time. They didn't have any electricity or light pollution in the nighttime. And so you could see the stars really, really, really clearly on a clear night. And Tycho Brahe is recording some of the most accurate measurements using massive, massive instruments for his day to be able to look at the stars and take down recordings of data of the movement of stars and stuff like that. And he was using all this data to try to support his idea that the Earth was in the center. But we all know the Earth is not in the center of the universe, not even in the center of our own solar system. And so the numbers, Tycho Brahe just couldn't figure it out. He came awfully close a bunch of times, but it just did not add up. And the story with Tycho Brahe, really quickly on a slight tangent here, sad story about how Tycho Brahe works. Tycho Brahe gets invited to the Danish court to have this dinner with the king of Denmark. And it's like a big deal, right? He's he's not a royal figure. If you're invited by the king, to go and show up at an event, you're going to show up and you're going to be on your best behavior. You want to leave a good impression, right? Social hierarchy and all that, patriarchy, right? He wants to go there and really set a good impression. And it's a long day of affairs. He's wearing his nicest clothes. He's going there, and it's all sorts of court entertainment. They have jesters and other things, songs and people playing instruments and stuff. And it's a multi-course meal, and Tycho Brahe, not wanting to upset the etiquette of the court, he has to, somewhere in the afternoon, he has to go to the bathroom, but he doesn't want to be rude and excuse himself to go to the bathroom and upset the other people around him, particularly the king. So he just holds it and holds it and holds it, eventually to the point where when the day is over, he finally goes home, but he can't go to the bathroom because his bladder ruptured. Okay. And so it causes, and this is it's a serious thing. If your bladder ruptures, you would have to go to the hospital. It's a really serious thing even in modern day times, because it can make you very, very sick. And so, but it does. And in this day, of course, it's a death sentence. And so it takes about 2 weeks for him to die. It's a very excruciatingly painful death. And it's because what happens is the waste content from your bladder creates infections in your body, and it goes to your bloodstream, and then you die. And so it's a horrible way to go, but that's basically how Tycho Brahe dies. And then his student Kepler, Johannes Kepler, who, we've named several satellites and telescopes and other things after Kepler. Kepler took all of that data that Tycho Brahe had recorded and started looking at it with new eyes. And Kepler ends up being the one that actually proves that there are the planets are revolving around the sun in an elliptical fashion. He finally found out why the math wasn't working, is because it's actually elliptical, it's not circular. And so this was a major discovery in astronomy. Moving on to slide 6, another notable figure of the scientific revolution was this guy. His name is Galileo Galilei, and he was the first to improve the microscope. The telescope. The thing about the telescope is it's not really invented by Galileo, but Galileo improves upon it. He makes his own. He creates a new design of a telescope, and it's a much better telescope. And, as he does so, he ends up, and again, it's not only the Catholic Church that these guys are questioning, they're also questioning the belief systems based on ancient philosophers whose ideas had been unquestioned for 2,000 years, right? These ancient philosophers, like we talked about in the first unit, of Socrates, Plato, Aristotle, and various others. Okay, there's another one called Ptolemy. Ptolemy had calculated Earth's circumference to 98% accuracy all the way back in like 200 some BC, 300 some BC. So for a long time, these ancient teachings were really, really, really valuable, and people didn't question them because they just assumed them to be right. There was this assumption like, and I know it probably sounds crazy. It's crazy to think about, but in the 1400s, before the scientific revolution, it's truly an amazing thing to think about, is that people in the 1400s literally believed, okay, humans have been around forever. Anything that could be known has already been thought about. There's nothing new to discover. We already know everything. And that's the thing that's so crazy and fundamentally different about society in those times comparative today. Today, we operate on the assumption that there's a whole lot of things out there that we don't know, right? Science is, and all of the whole reason that we have a STEM academy and all this other stuff is the notion like there's still a whole lot out there that we don't know, that we need to learn, that we need to discover, okay? New experiments that need to be run and replicated and analyze the results and find new treatments for illnesses and new discoveries about the human genome and other things like that. There's a whole lot of things today that we assume are like, we don't know them yet, but at some point in the future we will. We think of knowledge as coming from the future. In modern day time, we say we don't know it now, but one day we'll know more about something. That's how most people think these days, which is really odd because 500 years ago in Europe, the Europeans were convinced that everything that was ever to be known about everything, okay, had already been thought about, had already been discovered, had already been, written down by an ancient philosopher or something like that. That anything that anyone came up with today was nonsense because it's already been known. Everybody already knows it. They viewed fundamentally their knowledge as coming from the distant past. We view ours as coming from the distant future. That's a very big cultural difference. And the shift that initiates that change in thinking happens with the scientific revolution, as well as the thing that follows it, which is called the Enlightenment. So what are these guys doing? They're not only undermining what the church has been saying, they're undermining ancient teachings from guys like Aristotle or Ptolemy, or another guy who was interested in how the body worked. The idea of the body was based on something called the four humors, or the four fluids of the body, like blood, bile, I forget the other ones, okay? And phlegm is one of them, all right? And that any illness was as a product of an imbalance of your bodily fluids, essentially, is what they thought, okay? And of course, that's completely ridiculous. Modern medicine has completely disproved any of these ideas, but people believed it back in those days. And the kinds of things that they would give for treatments would be more as likely to kill you than to treat you for your ailment. Okay, but nonetheless, okay, it's just a really interesting thing to think about how different the framework of these people's thinking was in a time prior to the scientific revolution. But these new ideas are really frightening to people because new ideas are generally frightening to people, but especially new ideas that really shake the foundation of everything that you believe to be true about the world. And so this frightens the Catholic Church and the Protestant churches as well, who both condemn Galileo. The Catholic Church actually tells Galileo, you better not say anything anymore, and you better darn well not protect Copernicus, okay? If you come out defending Copernicus, you're going to be in trouble. And they say that to him in 1616, and he does keep his mouth shut for a while out of fear of what the Roman Catholic Church will do, but he continues his studies. And then in 1632, he writes a book. And in this book, in spite of what the Catholic Church had told him 16 years earlier, he comes out fervently defending the Copernican view of the universe, which was that the sun was in the center and not the earth. And immediately the Catholic Church is outraged. All right. And on the next slide, on slide 7, you can see a drawing of Galileo. I think that's done by Rembrandt, if I'm not mistaken. And then you move on to the next slide, and that is slide 8. And so Galileo gets called into the Pope, and the Pope basically says, we're going to force you to sign this document that says that you're wrong and that you take back what you said, okay? And so he signs a confession that Copernicus is wrong, that he was wrong for defending Copernicus, and that he recants his view, okay? And he is never allowed to go free again. The Roman Catholic Church keeps Galileo on house arrest. He's not allowed to leave his home for the last basically 8-10 years of his life. Okay, so he dies discredited and basically a prisoner of the Roman Catholic Church. And it's not until 1992, when I was in second grade, okay, that the Roman Catholic Church formally apologized to Galileo for forcing him to recant his findings, okay, about the universe, and putting him on house arrest for the last part of his life. Okay, so that's the story on Galileo. Really quickly finishing up here with the scientific method. Now, the scientific method is not really invented by one person, and it's really not even just invented by two people. It develops over time. It's not like somebody wrote the book like The Scientific Method. Step one, observe the world. That's not how it worked. The scientific method's kind of an amalgamation of ideas that came from different people at this time, that as we look back on how the best thinkers of the scientific revolution went about studying the world, we decided to take some of their ideas, combine them together, and we call it today the scientific method. And probably, if you haven't been living under a rock since you started kindergarten, you've heard of it before. Okay, it's something where you have this logical procedure for collecting and testing data. And the way that the scientific method works is, first you observe the world around you, you start making hypotheses about the world, educated guesses or questions about the world, you start running experiments to see if your hypotheses are true or false, with the intention of trying to prove your hypotheses false, because good scientists are always trying to prove themselves wrong, not prove themselves right. That's something to remember. Don't ever forget that. Okay, good scientists are always trying to prove themselves wrong, and so should you be. Okay, we always want to prove ourselves wrong, because if we're critical thinkers, we don't just rest on what we believe. We take what we believe and we run it through the rigors to see if our beliefs are actually supported by evidence and supported by facts and so on and so forth. Okay, and if they're not, that should be a moment where we reflect and we say, you know what, I wasn't right about that. That's a human thing not to be right about things sometimes. And now it's time for me to reform my opinion and take into consideration new evidence. That's what good scientific thinkers always do. All right. And then you experiment, you collect data, and you come to a conclusion. And then the most important point, you repeat that whole process, because without replication, you only have less. The replication is so important because you get more and more and more data every single time that you rerun an experiment. And that's going to be super important for the process for how these guys came about the scientific method. Okay, so the two people who contribute most to the scientific method, what time is this over with? 9:08. Okay, I've got a few more minutes here. The two most important contributors to the scientific method were Francis Bacon and René Descartes. René Descartes is a guy from France. Francis Bacon is a guy from England. They did not really know each other. They weren't like friends, okay? Guys, cool it. All right, now, we still use these methods that these two guys came up with in science today. To talk a little bit about Francis Bacon. Francis Bacon used a kind of method called inductive reasoning, which was collecting evidence, okay, and doing observation, all right, and asking questions, collecting data, all right. René Descartes used a different kind of reasoning called deductive reasoning, which is taking everything off the table that you know a thing cannot be. And kind of when you mix these two ingredients of inductive and deductive reasoning together, you kind of end up getting the scientific method. So even though René Descartes and Francis Bacon didn't really work with one another, they didn't collaborate with one another, they didn't even live in the same European empire, okay? But nonetheless, their two ideas are who we usually credit with allowing scientific thinkers of the scientific revolution in the 1500s and 1600s with being able to thresh out some new ideas and come up with new understandings about natural laws and how the world works. And increasingly what happens, and this is how I'll finish up our thing today, increasingly what happens is as these scientific thinkers are able to better and better and better attribute natural phenomena to laws that are unchanging, that are going to happen every time, that are known, that are predictable. Okay, the more we explain the world through these natural laws, these laws of nature, okay, where they are known, predictable, they are going to they're going to reduce the degree to which people explain the world through mystical events, spiritual events, religious events, divine intervention, because the more and more and more you can explain the natural world through known, predictable laws of nature, okay, the less and less and less you have to attribute to the influence that God had on everyday things. Okay, so that is really the direction, which is this kind of more secular direction that Europe is moving in this time. And yes, in the last 2 minutes here, I'll just tell you right now, there will be a homework assignment. I will post it as soon as I am able. It's going to be a vocab assignment, and I'm going to give you a handful of vocab words. I'm going to give you a vocab template, and all of it will be listed out for you. And so you'll have some vocabulary terms, and it'll be clear how you do it. I'll give you all the instructions for how you do it on Canvas. So be looking out for that later on today. But because I'm on a rapid fire schedule here today, I do have to wrap this up and move into third period and continue teaching. So for those of you out there, thank you so much. Have a fantastic day. Make good decisions. And thank you so much. Yeah, Recursive Resonance is coming out with a new song. So don't worry about attendance for today. Attendance will be if you complete the vocab assignment by Tuesday when it's due. Okay. All right. That'll be the attendance. Okay. Have a great day, everybody. Bye-bye.